Hey guys, today we're going to be looking at how to balance a redox reaction in a basic or alkaline solution. In the last video we learned how to do it in an acidic solution, and today we're going to take it a couple steps further, because that's all it takes, to go ahead and balance one of these in a basic solution. One thing to be aware of is the biggest difference between an acidic and a basic solution in this context is whether you have excess H plus ions or excess OH minus ions, hydroxide ions. Now the H plus ions represent an acidic solution, whereas the OH minus ions, the hydroxide ions, represent a basic solution. In any redox reaction, remember, we have to make sure that we are accounting for electrons in the actual process of balancing. So it's not just balancing for atoms, it's also balancing for charge and therefore the number of electrons that are being transferred in the process of oxidation and reduction. The steps to balancing a basic redox reaction or a redox reaction in an alkaline solution is actually almost identical to that of balancing in an acidic solution. So the first thing we need to do is make sure that the non-oxygens and non-hydrogens are balanced. Then we balance the oxygens by adding water. Then we balance the hydrogens by adding H+. Then we balance the charge by adding electrons. But then we add a couple of steps. So what we're going to do today is we're going to look through the steps of balancing in a redox reaction in a basic solution. And I'm going to show you the similarities and differences specifically between this and the last video. We're going to go ahead and do a practice problem where I'm going to show you the difference between balancing in an acid solution versus balancing in a base solution. Now the cool thing about the technique is that they start the same way. So the first thing we need to do is assign oxidation numbers, then separate into half reactions, and balance the half reactions individually. So let's go ahead and do that first. So manganese went from +7 to +4. Bromine went from +5 to +7. So when you're talking about oxidation, bromine was oxidized, manganese was reduced. So we're going to go ahead and write our reduction and oxidation half reactions. So oxidation half reaction is going to be the reaction with the bromine, all right? And reduction with the manganese. Now, like I said, the technique's the same with both balancing an acidic and a basic solution at this point. We're going to go ahead and balance the non-oxygens and non-hydrogens first. Well, bromine is already balanced, as is manganese, so we're good there. Next, we balance the oxygens by adding water molecules. So I'm going to go ahead and add one water molecule to the reactant side of this expression. That's going to give us 4 oxygens on the reactant side and 4 on the product side. And on this side, I'm going to add 2 water molecules to the product side. Now we balance for the hydrogen atoms by adding hydrogen ions. Here I've got 2 hydrogen atoms on the reactant side, so I need 2 hydrogen ions on the product side. And in the reduction half reaction, I've got 4 hydrogen atoms on the product side, so I need 4 ions on the reactant side. So we're balanced for everything except for charge. To balance charge, remember, we add electrons. My charge on the left side here is going to be -1, and on the right side it's going to be +1. So if I've got a -1 charge on the reactant side and a +1 charge on the product side, I need to add 2 electrons to the product side. And in the reduction half reaction, I've got a charge of 3+ on the reactant side, charge of 0 on the product side, so I need to add 3 electrons to the reactant side. Now what I've done is I've created balanced half reactions. I need to combine them. But remember, in order to combine them, I have to make sure that the number of electrons are the same. In order to do that, I multiply to the lowest common multiple, which in this case would be 6 electrons. That means I need to multiply my oxidation half reaction by 3 and the reduction half reaction by 2. I'm going to go ahead and rewrite them. There's my oxidation half, and now I'm going to rewrite my reduction half. And now I can combine into a single overall reaction. I'm going to go ahead and cross out as I do it. Okay, So everything's now written. I can now combine and cancel. In terms of canceling, you'll notice that I have hydrogen ions on both sides, I've got electrons on both sides, and I've got water on both sides. So I can cancel all of those things. Be careful with coefficients. What that means is that what we're going to be left with is this overall reaction. Now this overall reaction, if you look at it, we've got this bromate, so 3 bromates, plus 2 hydrogen ions, plus 2 permanganates, reacting to yield 3 perbromates, 2 manganese oxides, and 1 water. So here we have our reaction. We can check here for balance initially to make sure we did everything up to this point correctly. 2 hydrogen atoms, 2 hydrogen atoms, 2 manganese atoms, 2 manganese atoms, 3 bromine atoms, 3 bromine atoms. We've got 3 times 3, that's 9 oxygens, plus another 8 oxygens. So that's a total of 17 oxygens on the reactant side. 3 times 4, that's 12 oxygens, plus 4 oxygens, plus 1 oxygen, that's 17 on the product side as well. Balancing for charge. 3 times -1, so that's -3, plus 2, so that's -1, -2, that's -3. So -3 on the reactant side. If you look, -3 on the product side. So we are balanced for atoms and for charge, but we're not done yet. Here are hydrogen ions. Remember, that's an acidic solution. We need a basic solution. Here's how we do it. One extra step. We're simply going to have to exchange, if you will, these H+ ions for OH- ions. The way we do this is by adding hydroxide ions to both sides. We look at the number of hydrogen ions we have here. That's the number of hydroxide ions we're going to be adding. Just like a mathematical equation. If we add to one side, we have to do the same thing to the other. So, if we add 2 hydroxide ions here to cancel out these H+'s effectively, those are also going to be on the product side. So let me show you how we do this. Now by doing this, we have to again combine and cancel, but here's where we're combining. The hydroxide and the H+ would react together to neutralize and create water. So these two combined will actually create H2O. 2 of them. So I'm going to rewrite and I'm going to show you what I'm going to end up with. Now you can see we can cancel again. We've got 1 water on the product side and 2 on the reactant side. So we cancel the water and we're left with a final reaction equation, which, if you look at it, would end up being 3 bromates plus 1 water molecule plus 2 permanganates react to yield 3 perbromates, 2 manganese oxides, and 2 hydroxide ions. The hydroxide ions are in excess, telling us it's a basic solution. Now we can double check again, or triple check, I guess at this point, whether we're balanced. We need to make sure of it because, again, this is a critical factor. 3 bromine atoms, 3 bromine atoms. 3 times 3 is 9 oxygen atoms, plus another 1 oxygen atom, that's 10, plus another 8, that's 18 oxygen atoms on the reactant side. 3 times 4 is 12, plus 4, that's 16, plus 2, that's 18 oxygen atoms on the product side. Hydrogen, we've got 2 on the reactants, we've got 2 on the products. Manganese, 2 on the reactants, 2 on the products, and we check charge now. 3 times -1 plus 2 times -1, so that's -5 on the reactant side. 3 times -1 and 2 times -1, that's -5 on the product side. So we are now balanced for both atoms and for charge, and we are confirmed to be in a basic solution. I want you guys to try to balance this reaction in a basic solution now. Take a few minutes, work through the problem. If you get stuck or get an answer, go ahead and unpause the video, and we'll work through it together. All right, let's work through this one together. Again, as always, we need to first make sure that we are assigning oxidation numbers and then writing our half reactions for oxidation and reduction. So let's go ahead and do that. So there are my oxidation numbers. Selenium goes from 0 to +4. Chromium goes from +3 to 0. That means selenium has been oxidized and chromium has been reduced. Let's go ahead and write our half reactions. Now that we've written our half reactions, we can go ahead and balance each one. First, for the number of non-oxygens and non-hydrogens. In this case, we're good because everything is balanced already. Selenium's balanced, both reactants and products, as is chromium. Next, we balance oxygens by adding water molecules. We need to add 3 water molecules to the reactant side of our oxidation half reaction here. And we need to add 3 water molecules to the product side of our reduction half reaction. We now balance for hydrogen atoms by adding hydrogen ions. We have 6 hydrogen atoms on our reactant side, so we need 6 hydrogen ions on our product side. And in our reduction half reaction, we've got 3 hydrogen ions on our reactant side. We've got 6 on our product side, so we need to add 3 to our reactant side. We now balance for charge by adding electrons. 0 charge on our reactant side of the oxidation half reaction. And we look at and we see a 4+ charge on the product side. We need to add 4 electrons to our product side to balance. And in our reduction half reaction, we've got a charge of 3+ on our reactant side, of 0 on our product side, so we add 3 electrons to the reactant side here. Number of electrons is not equal. 4 on the oxidation half, 3 on the reduction half. Lowest common multiple between those is 12, so we're going to multiply our oxidation by 3 and our reduction by 4. We're rewritten. Now we can go ahead and combine and cancel into one overall reaction. All right, so now we look on both sides, we combine and or cancel. We can cancel hydrogen ions, we can cancel the water molecules, and we can cancel the the electrons. So let's go ahead and do that now. Okay, rewriting this. Okay, and we're going to double check to see if we're balanced here. 3 selenium atoms, 3. 4 chromium atoms, 4. Hydrogen, we've got 3 times 4, that's 12. Over here we've got 6 plus 3 times 2, that's 6, so that's 12. Oxygens, we've got 3 times 4, that's 12 oxygens. On the product side, we've got 3 times 3, that's 9, plus another 3, that's 12. So we're balanced for atoms. Let's check charge. Here on the reactant side, we have a charge of 0. On the product side, 3 times 2 minus, that's minus 6, plus 6, 0. Balanced for charge as well. Now remember, we need to make it into a basic solution. So we're going to take these hydrogen ions, and we're going to need to replace it with hydroxide by adding OH minus ions to both sides. In this case, 6 of them. Remember, the hydrogen and the hydroxide combine into water. The 6 waters and the 3 waters combine to 9 waters. All right, so we're going to end up with 9 waters on the product side, and we're done. And now we need to double check to make sure we're balanced for everything again. 6 oxygens plus 4 times 3, so that's 18 oxygens. On the reactant side, on the product side, 3 times 3 is 9, plus another 9, that's 18 on the product side. Hydrogen, 6 plus 12, that's 18. On the product side, 9 times 2, that's 18. Selenium 3, chromium 4, chromium 4. In terms of charge, 6 minus on the reactant side, 6 minus on the product side. So this right here is our overall balanced redox reaction in a basic solution. All right, so that wraps up today's video. Let's do a quick recap. Today we took balancing redox reactions one step further and learned how to balance them in basic solutions. Remember, you're going to be given whether it's an acidic solution or a basic solution right off the bat. So you need to make sure you know both techniques. The nice thing about balancing in a basic solution is it's essentially the exact same technique as balancing in an acidic solution, but we have to add those couple of steps at the end. I'd like to thank Anthony Wickett for writing, filming, and editing this video. I'd like to thank you guys for watching it, and I'll see you in the next one.